Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem remove duplicates from sorted list, second part of this LeetCode problem. Its index is 82 and it is the medium problem of the LeetCode. Okay, so this problem is totally related to the linked list. You can see the nodes over here, and we need to perform some operations. We need to modify the linked list, right? Okay, so I would strongly recommend you guys to move over this similar question section, and you should try this easy problem as well as this medium problem also. Remove duplicates from an unsorted linked list. Okay, then you should come to this problem, remove duplicates from a sorted list. Okay, so the very key point that should be quite noticeable over here is we have been given a sorted linked list, so we need to take advantage of that. Okay, so given the head of a sorted linked list, we have to delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. Okay, so if you consider this example, okay, so let's consider this one. This example, you can see this is our answered linked list and this is our linked list that is given in the input. So whatever the nodes that have frequency greater than 1, nodes with values having frequencies greater than 1, you can see that is going to be discarded, that is going to be deleted. So you can see frequency of 1 is exactly 1, frequency of 2 is exactly 1, but the frequency of 3 is 2, as well as the frequency of 4 is 2, plus the frequency of 5 is 1, right? So you need to delete all those nodes which have values having frequencies greater than 1, strictly greater than 1. So you need to delete this one, you need to delete this one as well, this one as well. When you delete these all nodes, you have to join this one with this one, and that will be our answered linked list. Okay, so how do you complete this entire process in one pass, having O of n time and O of 1 space complexity? Okay, so we are going to take advantage of a sorted linked list. That is, the linked list is given in a sorted form. It means that whatever the values that have frequencies greater than 1 are all going to occur in a consecutive manner. Okay, similarly over here. Okay, that would help us to modify the linked list efficiently. Okay, so let's look over the constraints as well. You can see number of nodes is going to be around 0 to 300, and the list is guaranteed to be in a sorted ascending order. Okay, so one of the ways is like you need to keep track of all the nodes with values in a set, and you need to keep updating the set, keeping in mind that whenever you face a repeating element, you need not to take that element, right? But that would be an hectic task to do that, because you need to make a new pointers, like every time you need to make a new node and repeatedly. But what we are going to do in this over here, we need to modify the given linked list. Modify. How we are going to do that? So the key idea is to keep track of the frequencies of all those nodes values which occurs consecutively, having the same number. Okay, so there are two cases, and the very first case is like delete the node. Let me write down delete. And the second case is do not delete. Don't delete. So let's talk about deleting the element first. Okay, so then we'll move to the second part. So when we are going to delete that element, when the frequency is greater than, strictly greater than 1. Okay, so first of all, you need to keep in mind that we are going to keep track of 3 variables. That is the current pointer, that is current will store the node address of that node which we are iterating for, that is the current pointer, and we have a previous pointer also, that is storing the node's address of the previous node, plus a new head. Like there might be the case like we need to modify the new head of the linked list, like the new head will be different from the original head of the linked list, right? So let's talk about deleting the case first. So you can see we are having this one, we need to delete that. For that case, our current pointer will be stored at over here. Let me denote it by C. Okay, so what I will do is like I will make a new node called next node, next underscore node, and I will assign this as C's next. Okay, so what it will do is like it will keep iterating to the right of the linked list until we found until we are having the same node value as of the current node value. That is, you can see this NN will be the next node, will be over here, and it has the value 3 having the same value as of current node's value. Then we will move the NN pointer to the next one, that is this one. Now we will find that this 4 is not matching with this 3, so we will stop it. Okay, so we will stop it, so our NN ends over here. And yes, we will also keep a track of a boolean variable that will tell me that yes, we have found a duplicated value. So you can see in this case, since we are having two nodes, it will return true. So I will have a found variable also that will be marked as true. Okay, so it means that yes, we are having a duplicate value, so we need to delete all these two elements. Okay, now just think about that. Our previous node will store the address of this one. Let's call it as P. Okay, so in this case, when we are having deleting some node, I need to assign P next as exactly equal to NN. You can see 2 will be assigned to as 4, right? So you can see, but our answer contains 2 assigned as 5. It doesn't matter, because when we are working upon these two sets of node, again previous will be modified, so it will become 2's 5. Okay, I will tell that also if it is quite confusing. So P's next will be NN, right? And okay, after doing that, you need to modify the current variable also, C. So C becomes NN. Okay, so yeah, I've written the code also. You can see it is quite accepted. So when we are having the found variable, you can see if previous is not a null pointer, I will assign previous as to the next node. You can see, so P's next will be NN, and you need to keep also in mind that P should not be a null pointer. Okay, because you know there you are starting with the previous assigned as null pointer. Okay, so suppose you are working on the very first node and you are having the duplicated values, so in that case previous remains as a null pointer. Okay, so you need to do this one if you are having found as true. Okay, so yeah, so let us talk about this set also, if that is being confusing over here. So you can see our new values would be, so NN will change, NN will not be assigned over here, and C will also change. So we will be having C over here and NN over here when we are working upon this set, right? So C and N over here, again you can see I will assign P's next to NN, so it would become 2 to 5, and C would be lying over here finally. Okay, so you can see finally we will end up with this set. So this was the case for when we are going to delete the node having the delete all those nodes which are having the same values lying consecutively, right? So let us talk about do not delete case. Okay, so let me erase all those first. So if you're talking about do not delete case, let's say we are over here, let me change the color. Let's say we are over here C, and my previous would be over here, and yes, we will assign NN as NN means next node as C is next, and we will keep moving NN to the next to the right of it until we found a different value. So you can see NN over here ends over here because 3 is not matching with 2, and also you can see we are not having any element having frequency greater than 1, so found will be marked as false. Found will be false. Now there are few of the cases that you need to handle. That is, you can see you need to assign P's next to NN. Sorry, yeah, you need to assign the like you need to change the value of previous to this position, and you need to move current to this position, right? Because you know there is not any repeating value having frequencies greater than 1. So previous will always denote the previous of the current node that is being taken into the answer, right? So when you found this NN over here, you need to move this C pointer to this position and previous pointer to this position. Okay, because this node will be taken, that is 1 and 2 will be taken. So previous would lie over here and C will move to the over here. So what you will do is you will do like P next, or sorry, you will assign P as C and C as next node, or you will also do C equals C is next. So you will assign C as NN. Now also you need to keep track of this new head also, new head. Okay, so there might be the case like you in this new head will modify. So what you will do is like whenever, like when you have encountering this case, you will check if P is a null pointer. Like when you are at working upon this case, you can see P lies over here. P is a null pointer. So if P is a null pointer, my new head will become current. Okay, so that is the case you need to handle. So if you look out my code, if previous is a null pointer, this new head will be exactly equal to the current, and previous becomes current, and current will move to the next position. Okay, so this is all about these two cases. You need to handle that efficiently. Okay, so if let me talk about this all the code in detail right now. Yeah, so time complexity of this entire operation is O of n, and space complexity is O of 1. Okay, so I will start with current as head pointer, previous as null pointer, and new head as null pointer. Okay, so I will mark bool as like found as false, and I will make next node as currents next, and I will iterate next nodes to the next position until we found a different value. You can see while next node is not equal to null pointer and current value is exactly matching with the next node's value, we will move this next node pointer to the next position and mark found as true and move this one. Now there exist some of the cases that you need to handle. If found is true, you need to erase all those elements lying over here having the same value. So you will check if previous is not equal to null pointer, you will assign previous next to the next node, and you will move current to the next node. If that doesn't happen, that it means that we have the elements having the frequency exactly as 1, you will modify this new head. That is, previous is a null pointer, then new head becomes current. Otherwise you will, if previous is a null pointer, you will assign new head as current, and also you need to modify previous and current. So you will make previous as current and current equals currents next, and you will return the new head. That will be your answer. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.